So the difference quotient formula is seen here, and it's very much the same as the slope formula. In fact, it is the slope formula. If you take a look at the graph that I've drawn up here, here's the point x, just some x value on the x-axis, and its corresponding f of x coordinate. So we've got the point x, f of x. If I slide over h units, however far that may be, our next point is x plus h. The corresponding y point is f of x plus h. And that generates another point, x plus h, comma, f of x plus h, which is just a really fancy way of saying x sub 1, y sub 1, and x sub 2, y sub 2. Now using our slope formula, we can go ahead and plug those values in using the fancier notation. So this is really y sub 2, which is f of x plus h, minus y sub 1, divided by x sub 2, which happens to be represented by this x plus h quantity, minus x sub 1, which is x. So when you simplify it, you have this f of x plus h minus f of x divided by h, which again is just the fancy slope formula. So now if I want to use the difference quotient and simplify, let's call it dq for right now, using a certain function, just given a function, and let's use the function f of x equals 3x plus 5. And I plug into the difference quotient. It's really, I'm looking at three different aspects of this formula. I'm first going to figure out what is f of x plus h, which means go to the f function, take out all of the x's that are in there, put in parentheses what's inside here. So put in the x plus h. Notice the h is inside the function, not just stuck on the outside there. So when I simplify this, this is 3x plus 3h plus 5. That's this part, or this piece of the formula. Now I'm going to compute this whole entire numerator. So that means step 2 is going to be to find f of x plus h minus f of x. We've already done part of this. We're going to take our answer from above and subtract from that the original, the f of x. Now I'm using a lot of parentheses here, and you really need to. The answer from above was 3x plus 3h plus 5. The original f of x was just 3x plus 5. When you distribute and combine like terms, you should notice something. One thing that you really should notice is everything in this original is going to cancel out with something in the first parenthesis grouping. The negative 5 goes, and the negative 3x is gone. And all you're left with should be terms, or a term, with just h in it. Which takes us to our third step of finding the entire difference quotient. In other words, we're going to take our answer from step 2 and divide everybody by h. And so for this one, when I take 3h, my answer from above, and divide it by h, I'm left with 3. That's not really that amazing, because if I take a look back at my original function and put it in y equals mx plus b form, y just being the simple name for f of x, my slope was actually 3. And that's what we found. And you're thinking, well, why not just tell you slope is 3 by looking at that? This works for linear functions, but if the function that you originally start with is not linear, you can't just look at it and tell me what the slope is. And that'll be our next example.